Okay. What I've done as part of the lecture is to really talk about our scientific understanding. We spend a lot of time going, there are thousands of concepts to explore and deconstruct how to understand. But it goes back to lesson design, and this slide and the next slide I showed you last week. Crucial is to first get an understanding of the concepts or concepts that we're going to teach, and then construct a series of lessons on how we may, in fact, deconstruct the meaning of those concepts. And again, I talked about the learning experience, so we're looking at 5 experiences that we're going to try to set up. Think about it in terms of its cognitive, affective, and cognitive. So it's doing, it's thinking, and it's feeling. With each experience, how does that work when you deal with that? The second thing is to make it real-world value, problem-based, as we did in the last 2 examples we talked about last week. That framework helps us a lot in terms of being able to introduce an idea in a lesson and build on that within that lesson. And we move on from that lesson to the next lesson and so on. So we talked about that last week. What I didn't spend time on is when we've got this framework of, say, engage, explore, explain, elaborate, and evaluate, what are some of the strategies within those sections that we will deal with? And so when I start to look at lesson design, okay, that's the framework I would use, and then I start to look at, okay, how am I going to introduce this idea at the beginning of the lesson? And then I need to think about what are the pedagogy, what are the strategies I'm going to draw on. So that's just a framework. That's how I may speak with the activities in it, but it doesn't tell me what I do in each part. So there is another aid that I want to introduce in this lecture. Well, talked about that last week. I won't go over that. I did that last week, so you're okay with that? Okay. When I look at engage, beginning of a lesson, I might pose a question. And what I may do is say, this concept is going to be focusing on our understanding of what is a bird. What I may have is, in fact, some examples. I might use the images of different birds. And then I might say, I might get the students to do a think, pair, share. Think, pair, share. In other words, think about this, have different images of different sorts of birds. What are common, what's different? Now that's the cognitive part. So then high order thinking, like comparing a number of different examples of birds, for instance, and I do a cognitive learning, think, pair, share, so it's in that support. And then I get them to think, okay, what have you learned about this? In terms of their own learning, individually. So when you start to look at, so when I look at an activity, sorry, I'll start again. When I've got the framework, engage, explore, explain, elaborate, and evaluate, I then look at each part and I say, okay, how am I going to actually orchestrate that? What thinking is going to happen in this part of the lesson? What sort of support I'm going to be using in terms of cognitive learning? And the third point in terms of how is it going to be internalized for the student, for the individual. So this particular scaffold I found, it's quite an old one. It's called Blueprints for Effective Learning and Teaching. It's by Robin Fogarty and James Belanca. They were the 2 educational theorists that introduced where I got this idea from. It was sort of, we're talking about 20 years ago, I think, almost. But what I look at when I look at learning, I want to create high support, high content, and high challenge. High support, as much as possible, and as you found yourselves when you were going through the tutorials, you were in groups, you were working together with others, and you were sharing ideas. That gave you the support that you required. The cognitive part is the thinking, And then the third, okay, what did I learn from my own knowledge previously to what I've learned here in terms of my internal thinking of it. So I find that that's a really useful scaffold so when I start to think more carefully about my lesson design, especially for some of you that are going into your schools next week, there will be lessons that you will have to teach. So think about the framework that you use and then the strategies that you use within each of those. Here are some strategies that I would suggest that you use at the cognitive level. And they are called graphic organisers or cognitive organisers. Have you seen them before? Some of you have. Use one at the very beginning, the web diagram, or the association map. What I got you to do at the very beginning of today's lecture. The idea in the centre, and what are the associated ideas with that? Well, if I'm doing a brainstorm, a web diagram, I'm just simply collecting a whole series of words. Now, I'll be putting this up on the view slide, by the way. A Venn diagram, which we'll do a little bit later, but if you're comparing and contrasting two ideas, I'll give an example shortly. And then the fishbone diagram, when you're looking at cause and effect. So, it could be the blue box is the effect, and the various causes would be the spokes coming up from that. So, what were the causes of World War I, for instance? There are a number of things that, in fact, caused World War I, so you'd be able to use that graphic organiser to help assess that. So those are helpful aids to help with the higher order thinking, the cognitive part. The cooperative learning also helps provide student support. I've already talked about think, pair, share. I often do that, especially at the beginning of lessons, to think, pair, share, so that there's some confidence in understanding and then get various kids to sort of contribute to the discussion. Or four corners. Well, I know with the two groups that I ran the first week formed a continuum. Here I can actually say four parts. There are four parts of the room in terms of where you would fit. So, for instance, strongly agree, disagree, strongly disagree, or hot, warm, cold, or freezing could be ways of doing it. Okay? Or the expert jigsaw. Now, you probably did that the other day. Last week you were working on traffic lights and the electric car. So, we had two members of one group go and work on electric car, two members working on traffic lights, and then the idea, we ran out of time, but you would come back and you'd share what you've learned. Okay, so I often, if I was teaching, say, I did this with the Year 7, Year 8 class, I was teaching about the human body, got the students to break up into groups of 4, and then each member of the group became an expert on the digestive system, or the circulatory system, or the respiratory system, or the excretory system. So they went with the experts on the various 4 areas. They did some work, and then they would come back and teach their home groups. So I would talk about home groups versus task groups. So that is a form of jigsaw. Again, it's a way of organising the way you would facilitate the learning in the classroom, so that when you go back to your design, you need to think there's a framework that I use, but what are the sorts of strategies that I'm going to use throughout to actually build this social learning happening in the classroom. Any questions on that? Okay, so I'll only need you to read that yourself to give a bit more information on that. The third, and I often do this, you could do this anywhere through the lesson, but certainly at the end. And I, as a teacher, future, I encourage my students when they teach their first lessons is to look at those I call Mrs. Potter's questions. What were you trying to do? What did you do well? What would you do differently next time? What help do you need? So in that particular lesson, but if with kids in terms of whatever task you set them. So those reflective questions, which are metacognitive, okay, which is getting them to think about the process of the learning, helps them to become better learners in the end themselves. Or a PMI, pluses, minuses, and interesting aspects. Or we can look at, I've got time to talk about DeBono 6-hat thinking, but you can certainly look that up. But that also provides a good scaffold for you to develop your strategy with questioning. Well, I sometimes say, okay, what I want you to do is to put on your red hat. Your red hat is to do with feelings. So what do you feel about that? So I often in a classroom would say to the kids, put on your red hat, or put on your yellow hat, or put on your green hat. And what I'm saying is that I'm after a particular type of thinking. And it provides a nice scaffold for the kids to know what you're doing. A KWL. What do I know? What do I want to know? And what have I learned? So, what do I know about birds? What do I want to find out about birds? And at the end, what have I learned? So those strategies start to think about how you orchestrate your design. You've got the pedagogy, those sitting in. In the latter part of this lecture, I'm talking about 8 ways of thinking. You're going to find that that's going to be a really powerful tool for you to actually improve your teaching and build in more quality learning in your teaching. I'll come to that shortly. Just got to watch my time, so I'm going to whiz through a few things shortly. Okay, say if we're doing a unit on pets. Now, what are some pets? Quickly. We're going to do this very quick. Cat. Dog. What? Chicken. Any other pets? Sorry? Hamster. A hamster, yeah. Okay. All right. Rabbits, and so on. Birds, and, okay, reptiles. Some people have got pet snakes. Not that I have a pet snake, but... Okay, so if we were to develop a unit on pets, we may want to then build up the conceptual understanding of, okay, well, what are the characteristics of some of these pets? So if I ask the question, now 2 common pets are cats and dogs. So just very quickly do a little exercise. This is in terms of the thinking part, compare and contrast. What's common to cats and dogs? 4 legs. Tail. Yep. Tail. Yep. What else? Sorry? Domesticated. What type of covering have they? Fur. Okay. Warm or cold-blooded? Warm. What type of animal? Cattle. Good. Okay. So there, that would go in the middle. So what's different about the two animals? Okay, one of for instance, a cat will go meow. Okay, make different sounds to a dog will go bark. Okay. What else? One chases balls. Oh yeah, okay. You could. I mean, the dogs would chase the ball. You can train a dog to do that. Sometimes they say you can train cats, but maybe you can't. You can. There you go. Yeah. I think you can. Yeah. Again, it depends on what type of cat you may have. Sorry? Yeah. Okay. Yeah, and their vision's different. And also their tongue. If you had a cat with you, in the hand, really like a real rough, okay, and so on. So you can start to really look at the differences, and kids love doing that in terms of what's different about a cat and a dog and so forth. And if we had time, I would get you to do the task, but I've actually done the answer for you. So the, oh yeah, they're carnivorous. What's a carnivorous? What does carnivorous mean? Meat eating. Yeah, so they're meat eating, four-legged, they're mammals and they're furry. Cats are difficult to train, not saying that can't train them, but they are difficult to train. They've got a rough tongue, whereas a dog's got a smooth tongue. Climbers, and dogs are swimmers. Cats don't like swimming. But some do. Yeah, and bark. Okay, so cat will purr. Now, a cat, and this is biologically, has a vertical iris, whereas a dog has a round iris. So that's in terms of difference. And cats have retractable claws. But certainly there's a bit of research, but that's certainly more of a high cognitive task in terms of trying to find the differences. And we started to sort of develop our understanding of what is a mammal, different types of mammals, as an example. Okay. So just to sum up, the children construct their own understanding from their own bits of experience in an attempt to organise the experience. By creatively and actively seeking to make sense of their own world, children are attempting to achieve the same types of things that the scientific and technological community is attempting to do. So we often get our kids to classify. That's a scientific process. Imagination and creativity are all the core of the scientific processes of hypothesis formation. Now let's go back to what's an hypothesis? What is an hypothesis? An educated guess. Or simply guess. We hope it's educated, but yeah, in terms of we might say, and that builds from our own experience trying to explain something. So we often go and test our hypothesis. So it has to be an educated guess, but it actually has to be testable. Well, and so we start to develop that. Okay, just to talk a little bit about how we may get kids to think about concepts a bit further. Use of humour, jokes is sometimes very useful. And for instance, if we look at this one here. A neutron walks into a bar, orders a beer and begins to open his wallet when the barman says, "For you, no charge." Now, you probably wouldn't get that unless you knew something about what a neutron was. So what do you need to know before this is amusing? Okay? So you need to know about, okay, here we've got the model of an atom. And so electrons are very small and revolve around the nucleus of an atom. At high speed, they have a negative charge. And you found this in your first week when you started to have a voltage across two ends of a wire. And what happened was current was pushed through. So we had electrons, because the electrons are on the surface of atoms. So the electrons were made to move along the conductor. Okay, protons are part of the nucleus. They have a positive charge. Neutrons are also part of the nucleus. They do not have a charge. So now this is funny, going back to the previous joke. What about this one? Two atoms bump into each other. I think I've lost an electron, says one. Are you sure? Asks the other. I'm positive. Okay. I use this with my Year 9 class, so, you know, my students never really appreciated my sense of humour, but never mind. You may not either. But it just illustrates the point that we can use humour to get a concept across. Heard about the NASA restaurant on the moon? Great food, no atmosphere. Okay. So what do you need to know about that to be funny? So obviously you need to know that on the moon there's no atmosphere. Okay, so